Hello everyone, my name is PARAG PAL and I'm here with a new numerical of the mechanics. Okay, so guys, in this video, basically this video for a basic knowledge of the engineering mechanics for a B first year student. Okay, so now let's come to the example. Here some supports, which is a hinge support is to be here, and a roller support is here. Roller support is inclined at a certain angle of degree, which is 30 degree. Okay, and some point load with some inclinations to be given over here. So what we have to do, we have to find the reaction at support A and B. We have to determine the support reaction at A and B as shown in a figure. So basically, during the find out of the reaction, this sort of example is coming in your examination around for according to me it's around 5 to 6 marks. Okay, how to overcome the situation where some people don't know how to solve the numerical. First of all, if it is having some inclination, then resolve it. Okay, then resolve along the x and y direction. Okay, whatever the point load is acting along the axis, then there is no need to resolve all these things. But if it is acting inclined at a particular beam, so you have to resolve the thing along x and y direction. Okay, this point is acting toward the center, and if it is going outward, that means if it is a section, okay, the force going from this point to over here, so it is going away from the point, away from the center, and if it is coming to the point, it is toward the center, like this. Okay, so now basically the beam is providing all the data regarding what the forces are coming on the particular beam. Okay, so now along with that you have to resolve all these things. Now the beam is this roller support is inclined at the 30-degree angle, but it's basically, if you minus the 30 degree from the 90, so it gets 60-degree inclined from this side. Okay, so now how to solve the numerical? The first answer is, you have to take the moment, summation of moment at point A or at point B. So we are going to take the summation of moment at point A is equals to 0. Okay, so now what you have to do, if you taking the summation of moment at point A equals to 0, then the remaining all the forces are acting at a point A as a moment. Okay, now if I'm talking about the resolution of the 60 kilonewton inclined portion, so it is going on the 60 this direction and 60 this direction with the cos and sine angle. Same thing with this one, same thing with this one. Okay, the angle, there is a one thing is important. If your alpha or any angle, sort of angle, whatever it is, you have to take the name of that angle. I take the name as alpha. Okay, so that particular alpha, if it is connected with the x-axis, so your x component is force with the cos, that means cos component. If it is connect with the y component, like this side, okay, so your component will be cos, your component will be sine, I'm sorry. Okay, so x axis is going for a cos, y axis is always going for the sine angle. Okay, so basically you have to resolve, that means 60 cos of 60 sine of, okay, 80 cos of 80 sine of, then 50 cos of 50 sine of. Okay, that means you have to resolve these things. Now basically I am not resolving over here, this is the one book example why I am taking over here, because some students are having some problem how to solve this numerical. Okay, why I did not make this video in Hindi, because I wanted to try to make my English better. Each and every civil engineer don't have proper English, no, so that's why I make all videos in English, and Hindi complement too. Okay, so now how to solve the numerical? First of all, you have to go for the point A where the all summation of moment is getting 0. Okay, and remaining all you have to take some moment like force into perpendicular distance at point A. Why I have told you that you have to resolve all the forces, inclined forces. There is if the force acting along the axis, there is no need to resolve. Okay, but if it is axis, if the force is acting as an incline, then you have to resolve. Why? Because the force per perpendicular to the distance, that's the formula depends on a moment. Okay, so you have to formalize the condition of the moment, you have to go through all these things. Okay, now let's go to our calculation. We are taking the summation of moment 0 at the point A. So how it is to be belongs, support, I take the RB support over there, RB into sine of 60, this angle of 60, it going like this and this. Okay, so RB into sine of 60 multiply by 6, that means this is the force with the component of the y axis multiply by distance, which is 6 total distance. Okay, minus, this is going to plus. Why this is plus? Because the force rotating the clockwise direction. Okay, you just follow your watch, the clockwise direction and anti-clockwise direction, all these things may be think possible. Okay, now minus 60. Okay, here what they have here, they take some relation over there. Let me see. Yeah, okay, so these all the movement are taken at that point according to this one. Minus 60 sine multiply by 1. Okay, minus 60 sine multiply by 1. Then minus of 80 sine 60 multiply by 3. Okay, what they had to do, they take all the data and according to it RB equals to 100. Okay, you got all the movement at point A and after that you get the RB equals to 100. Then after getting the movement, you have to summation of the all horizontal forces. Okay, all the summation of horizontal forces equals to 15.9293. How does I take the summation of forces? The all forces getting all horizontal direction, you have to take plus. If it is going this direction, it is plus. If it is going this direction, it is minus. Are you clear? Now same direction, upward positive, downward negative. So you have to take all the summation of forces of the vertical forces. Okay, after getting summation of movement, summation of all horizontal forces and summation of all vertical forces, you have to go for a determination of the support reaction of R. R is nothing but that means the reaction at point A is nothing but under root of summation of F horizontal forces square plus summation of vertical forces square. So okay, so you have to take under root and square of that all horizontal and vertical forces and adding both of them, so you get this RA. And after getting RA, yeah, there is one formula that there is a reaction of the support A is to be you find out. Now after that you have to calculate where the resultant of that force RA is acting toward, like this. Here a force is acting. Okay, we have to determine at which inclination, at which alpha inclination the force is acting. Okay, there is a resultant in acting. Let's there is one example if I wanted to give you. There is my pen. Okay, here is my pen. If I throw at certain angle, I don't know what is, if I taken at the, yeah, I've thrown it. Okay, I know the what is the magnitude, I determine the magnitude, I know the vertical and horizontal forces, but it is essential to determine at what inclination the angle, the resultant is going on. Okay, this is called as a resultant. Okay, so hope you understand. After that, there is a one formula actually. RA equals to, that means the resultant at point A equals to under root of horizontal forces square plus vertical forces square. After calculating that thing, you have to go for the determination of the angle. But here the angle formula is different because it is a tan inverse of vertical forces upon horizontal forces. There is no any squares. Only the formula is like tan theta equals to vertical upon horizontal, but we have to determine the alpha only. So tan inverse equals to vertical upon horizontal. Here it is. Okay, so like this you can calculate all the forces and the forces with the resultant with a particular angle of inclination. So hope you guys like my video and like my lectures too. You have to go to my website. Please go to my website. There you find out the proper lectures of the civil engineering, mechanics and the gate civil engineers too. Okay, so and I believe in the e-learning actually. Okay, because one friend can teach properly to the another friend also. Okay, so you all are my friends and I wanted to teach you all in a proper manner. Whether I don't get some time, but I always took up some time for you guys. I makes video in Hindi and English too. Okay, I don't know another language because I'm already Marathi work. Okay, so guys, thank you for watching my tutorial. Please like my channel, please subscribe, please like my video and subscribe my channel and visit my website www.civilnotes.com. Yes, and basically I created one Android apps too in a Google Play. You can go there, and if you are civil engineer, then go over there. Okay, and type the structural analysis lecture. Okay, there is my app. You download it. There is all the videos of the structure detailing, and after that I put all the many more data for you guys. And thank you for watching my tutorial. Bye bye.